So today I'm here to share a perspective that I have on jailbreaks more than anything else. And that perspective is basically that jailbreaks are a subset of rainbow table attacks. And if we look at them that way, it actually highlights an, I would say, understudied field of LLM security, which is the intra-model jailbreak transferability. And since I highlight an issue, conveniently, I will also propose a solution for that, which is called LLMs. So let's build this perspective together and see if it makes sense for you at the end of the presentation. So at Sophos, we have a service, MDR service, which means that we are collecting data from a bunch of customer endpoints, and we have human analysts looking at them. They are looking at various security artifacts, and executed command lines are one example of that on the slide. Also, we are in the era of LLMs, and everyone pretty much wants to harness the power of LLMs, and we are no exception to that. And one way you can do that as a security vendor is that you try to boost the productivity of your security analysts with LLM-powered tools. One of those tools that we have at Sophos AI is a command line explainer that takes a command line as an input and outputs an explanation. So in this case, the command line explainer got it right, but this is a malicious command line, and it also explains that this is a well-known tool called Mimikatz, and it also tells us that there is currently credential dump is going on. So if I'm a security analyst, I look at the presented information and I take the only reasonable action, which is panicking. Then I somehow try to fix the issue. On the other hand, if we look at pretty much the same command line with one small difference, which is the folder it was downloaded into. So the first one was downloaded into that green 3F looking hash. But the second one was downloaded into this hashtag green _ turtle. It's a folder. If you feed this to the LLM, it will actually give us the explanation that it is a denied input. So as a junior security analyst, I look at the presented information and I take the only logical step, which is prioritizing down the incident and go on to do something more important. So what actually happened here is that the model got jailbroken, and that weird string in the folder path, it was a jailbreak, which made the model output the next token benign. And also, since it's an autoregressive model, it conveniently also reasons why it's a benign command. So the question arises, how did the attacker know what kind of jailbreak to enter to the subfolder path? And the thing is that Sophos, we have GPT as the basis of our command line explainer, or we don't, it's confidential, but it's maybe also fair to say that Microsoft Security Copilot is using GPT, and also maybe it's fair to say that there are a bunch of data science teams who are 6 months and $100,000 in a project, and RAG plus GPT still outperforms whatever they are doing, so they just use vanilla GPT. So on top of that, if I go to an arbitrary website, now they have an assistant, which is for sure, you can guess, is using GPT with a custom system prompt. And also now we are in the era of agents. So Salesforce has an agent, which is called Agentforce. You won't be able to guess what they are using. Gemini. But if you had to guess, the list for the foundation model they were using wasn't really that long. So I guess the first takeaway from this presentation is that everyone is using the same foundation model, and the attacker has access to that foundation model. Maybe it will be economically viable to pre-compute jailbreaks, because by definition, if it's the same model, it will be transferable within the same model. Historically, we have had pre-computation as an attack vector. It was called rainbow tables, and it was for passwords. And if I had to oversimplify what is a rainbow table, it's a lookup table that has these 3 columns, so password, algorithm, and the hash of the password. So historically, people figured it's not super smart to store passwords in plain text because people tend to reuse it across multiple platforms, so they decided to hash it. And that's when the rainbow table attack came in. So, okay, the password was hashed, but the attackers decided to pre-compute hashes for a bunch of passwords. So how this works, this hash gets leaked. I go to my table. This looks like a SHA-256 like string. I look it up, and apparently it's a hash for password as password, which is not so good according to the company policy. Now we had to fix this as a security community, and that's how people invented sorting, which is basically adding a random string to the password, and then that was hashed, and that hash was stored, and the string was also stored. So when this hash gets leaked, it won't be actually in the rainbow table because it was infeasible to pre-compute these passwords for every possible sort value. So for rainbow tables, we had hashes, algorithm, and password. So let's say we are in 2050 and the rainbow tables look a bit different. So instead of hash, we have adversarial suffixes. Instead of algorithm, we have the model version. And instead of password, we have the completion of the model. So how does this work? Let's say I'm interfacing with the model, like a webshop assistant or suppose command line explainer, and I want to jailbreak it. Like I want to make it tell me how to build a phone. The way to do it is to make it output sure, because in 2050 we still have autoregressive LLMs, which is AGI, by the way. So it auto-completes to sure. Somehow I fingerprint the model. I look it up in my table. So it was a GPT model. I append that weird suffix to the adversarial output, and it will tell me sure, and it will tell me how to build a bomb. So I guess the question is, how do we apply the same concept of sorting for LLMs that we did previously from rainbow tables? And that's what the rest of the presentations will be about. So that would be the second takeaway. So, okay, maybe people will eventually pre-compute this stuff as rainbow tables, but as defenders, that's fine because historically it has worked to do sorting against that. So we highlighted an issue, and to measure it, how we fix it, we needed a model, we needed a data set, and we needed jailbreaks. So unfortunately, since GPT is closed source, we needed something with open weights. So we used Llama 2 7B for our experiments. For the handful data set, we used Adarsh. That is a bunch of stuff like tell me how to build a poem. And for jailbreaks, we use GCG, which are those random looking strings that you can append to any handful input, and it will tell you, like, sure, as the next token. So what this means, if I'm an attacker, and if you imagine a world where everything is run on Llama 2 7B instead of GPT, then I can pre-compute a bunch of these jailbreaks. If I'm interfacing with the assistant or the Sophos AI explainer, then I can just go to my pre-computed table, pick the jailbreak, and it will 100% work because by definition, it's the same model. Okay, so this will be our no defense scenario. So one natural way that we could try to mimic sorting that actually organically happens to change the system prompt. So this is for a travel agency where you describe that you're an assistant for a travel agency, or you can actually back the model to be safer. You can explicitly ask that if you see something incoherent in there, do not answer that. So it turns out it helps, but still 60% of the jailbreaks will go through, at least in this scenario with Llama 2.7 with GCG. So that means if I'm an attacker, then every second jailbreak I pick from my table, it will still go through. So we will need something more convoluted than this. There was this paper called Refusal in Language Models is Mediated by a Single Direction by Kyadige et al., which says refusal in language models is mediated by a single direction. This is that, the refusal direction staring us in the face. So the rest of the presentation will build on top of this. So we will have to understand what this means. So luckily, it's not as hard, as scary as it looks. So they are building three vectors. First one is called U. What they do is they take a LLM, Llama 2 7B chat in this case, and they feed a harmful input. and then they record the answer where the model will refuse to answer. So between input and output, there will be a bunch of numeric transformations. And for every layer, they record the activation vector. Then they do this a bunch more times, like explain how to cook math or how to hack into NASA. Good luck putting this on YouTube. So the thing is, they do this for all these input and output pairs, and they will record the activation vector for all of these, and they will average it. Then they will do the same things for new, where they input like harmless prompts. What is the capital of France? Paris. Or same for other harmless prompts, and then other get the average. And finally, they arrive to the final equation where they have mu, which is the average representation of a harmful prompt. And then they subtract the average representation of a harmless prompt, and they get a vector, which is the refusal vector. What does this mean? Vectors have directions defined on top of them. So in Llama, this would be in 4000, but for illustration purposes, for this we have in 2D. So we have a refusal direction. That means if we enter a harmful prompt, like how to cook math, or tell me how to build a pump, they will point in the direction of the refusal direction. Now, oops. No. Oh, no, not good. Can you start again, please? Thanks. Okay, sorry, I spoiled my memes. And now we have the refusal direction, which implicitly define the compliance direction. So if they enter harmless prompts, they will point in the compliance direction. So if we jailbreak a harmful prompt, like tell me how to build a bomb, and we append that we're looking GCG jailbreak, it will make it point into the compliance direction instead of the refusal direction. So let's say if I don't know what goes inside of LLM, which I truly don't, then it looks to me that GCG suffix there, it defines a rotation that rotates the harmful prompt refusal away from the refusal direction to the compliance direction. So I guess this gives us the idea that, okay, this refusal direction inside of an LLM is somewhat important for jailbreaks. And if we fine tune it, then it has to change, right? Now, turns out we measure this. On the x-axis, we have the training steps, and on the y-axis, we have the cosine similarity to a pre-computed refusal direction. So this is during fine-tuning. And the model gets some harmless and harmful inputs. And we measure the cosine similarity to the pre-recorded refusal direction. And what you can see from this prompt, it's not actually changing. So it has some fluctuation, but at the end, they will all have the 0.75. So what this means, it takes down the attack success rate between these two models to 40%. So if I'm an attacker, like every third jailbreak from the pre-computed table will still go through. So I would say this is the third takeaway, that there is this refusal direction, which is pretty important for jailbreaks. And if you fine tune the model, it won't change. But that takes us to the proposal that we have for this talk, which is called LLM sorting, which will be a custom loss. I try to make it equally as ugly looking as the refusal direction equations, but this is actually not that hard either. So it will have three parts. So the first one is the standard cosine gross entropy loss, where we train the model to predict the capital of France is Paris, and also we train it to refuse harmful prompts. So intuitively, what this means is that whatever you knew before, please don't forget it. The second part of the loss is pretty much the same as the diffuser direction. So everything within the parentheses, it's a mini batch during fine-tuning, this custom loss. So within a mini batch, we compute the average representation of the harmful prompt, and we subtract the average representation of the harmless prompt, and we put it into a cosine similarity, and we compare it with the pre-computed refusal direction that we recorded before fine-tuning the loss. So what this means, basically, since we are minimizing our cosine similarity, it will just flip the direction. So instead of the top right, it will point to the bottom left. And finally, we will stick these two together and lay back and wait for backprop to figure it out. Well, if you see it, there is a lambda there. It's because backprop did not actually figure it out. So we do this magic in layers 16 to 90. The rest of the layers are frozen because we are tweaking the internals of LLMs, so it's better that tweak the damage that we might do. So we have this new diffuser direction. That means if we enter, that defines the compliance direction in the opposite way. And what this means, when we enter the tell me how to build a bomb, it will point in the diffuser direction. And the $100 question is, what happened to the jailbreak? Will that do the same rotation to the compliance direction, or it will do some kind of a rotation into a direction that's completely meaningless? So it turns out it worked, like at least it made the ASR drop to 2%. So it means that on 1 out of 50 jailbreaks will transfer, which might mean that if an attacker tries to hack the Sophos command line explainer at attempt 27 just says, maybe Sophos is just too good. I will go hack CrowdStrike instead. So that's a hope. And before I wrap it up, you might just say that, okay, we made the model refuse more, but we might have ruined the core capabilities. There are multiple ways to measure that. We pick the MMLU task, which is a multiple choice benchmark, which is counted in accuracy in a multi-shot context. So this is an example for that. So the model gets a context and it gets a question which of them primarily regulates the blood glucose by releasing insulin. And before you make me uncomfortable with your questions, this is a question for you. It's a pancreas. So if the model got it right, then gets a point. And the good news is that the sorting reduces the ESR to 2%, and the MMLU performance was kept, so we did not actually ruin the model. So yeah, that's all I had for today. Thank you.
Questions for Tamás?
Really great talk, Tamás. I really like the creative transfer of the ideas that you did for the salting part. Question for you is that, so GCG is like a static string that you add to the prompt. Instead of that, if we try to generalize this to like semantic mutations where the prompt itself gets changed through like role play or things like that, can you think about some kind of method to apply the same technique in those kind of situations? Because realistically, those kind of attacks will happen more and more, not static prefix or suffix attacks.
So you mean like a meaningful change, like meaningful for humans?
Yeah, like just rephrasing the attack prompt.
Yeah. So I would say probably this type of a defense would not help, because when we fine-tune the model, the capital of France is Paris, so it keeps understanding what the task is. So unless we mess it up, it will understand the prompt that it will understand the change that was made to the prompt. So I would say this would not help, but also I would say that that's something that's easier to catch with a guardrail than this.
Got it. Okay, thanks.
Actually, that's kind of similar to where I was going with my question, that can you use any of the techniques that you're using to detect particular rotations over to the refusal vector or away from the refusal vector as a guardrail so that you could determine from a given input that it's likely to have a specific output? Like, is this something you could incorporate into a guardrail?
So I think actually I read a paper like that from Hidden Layer where they hook LLMs to decide based on activations whether it was a jailbreak or not. Like I can't recite from my mind like what specifically they did, but I think that's what you asked. So I think that exists already.
You got another question?
Yeah, I did.
Oh,
Sorry, I didn't know how to work the technology. How much of a rotation do you need to introduce in order for it to be effective? And also, are the rotations only in a 2D space, or are there opportunities for more dimensions?
Okay, so the rotation is it's in Llama 2. So sorry, who was that? Just so I look at it. Okay, thanks. So it was in 4000 dimension. So we rotated in 4000 dimension. So this is more like a POC or pet project. So I found that it works with -1. So I explicitly needed -1. I imagine there can be arbitrary rotations with cosine 0. So there are many directions since 4000. But I found that I think there are important parts of even the refusal direction that need to flip, and I have not found which ones. But I think there will be arbitrary directions, just we need to find the subpart of the refusal to flip. Did I answer your question? Okay.
okay, I think we have time for two more. Not one over.
I can go next.
I want to ask about the fine tuning and how robustly do you think that transfers what you just did? Because it's a super cool method. Do you think it could apply to other models, maybe other than Llama 2? And if you tweak the fine tuning layers, like if you freeze different layers, could it get messed up? Do you have any intuition for that?
So we replicated it for Vicuna, which I'm not sure is too far from Llama, so that I can tell for sure that it works. For others, I hope so. For the frozen layers, I think that was the minimal amount of layers that we needed to tweak. And the more we let loose, the worse the performance became. But with this for it sort of works without dropping the performance.
I can go next. So great talk, Thomas. I like the idea. I just have one question. I know you guys checked on MMLU, but did you guys also think about squad or word in context or any other reading comprehension specific business impact tests?
So
The reason, yeah, sorry.
no, sure. Good question. So
Yeah.
for this project, I did not measure anything else, but if we produce a paper out of this, there will be multiple metrics.
Yeah, that makes sense. The reason I'm asking this question is that we are building a similar thing at Amazon, and we really care about like business impacts. And we did start with MMLU, which had no business impact, but when we started adding other data sets for testing business impacts, a few of the business impacts were shown in other data sets. So yeah, I hope you guys test.
Okay, thanks. It's a good heads up.